So hello everyone, today in this video we are going to see how we can just delete a particular node from a binary search tree. Deleting a node from a binary search tree, you have to face three cases. One case is that whenever you want to delete a leaf node, and second case is that when you want to delete a node which has only one child, and third case is that when you want to delete a node which is both the left and the right child. Now let's consider these three cases and see how we can solve the problem in these three cases. Whenever, let's discuss about the first case. Whenever the node is the leaf node, what you have to delete, let's suppose you take the example of 25. If you want to delete this leaf node 25, then you have to do nothing. You just have to delete that particular node and everything will be done. Now, for the second case, if the node is not the leaf child, it has only one child. Let's suppose it is in the, it might be the left or it might be the right. That doesn't matter. It has only one child. Now, if we take the example of 22, then you can see that it has only one child of 25. And now, how we can delete in this particular situation? You just have to connect the parent of that node with the child, and you have to delete that particular node. So then the new binary search tree will be like that. The 25 will be the right child of 20, and that's it. Now let's discuss about the third case, how we can delete when a particular node have both the left and the right child. If we consider this case, let's take the example of 8. Here you can see it has both the left and the right child. Uh, right child. So how you can delete in this particular scenario? When you have this kind of a scenario, you have to do one thing. You have to find out the minimum value of that right subtree of that particular node. So right subtree of that particular node 8 is basically this tree, this subtree. What is the minimum value of this subtree? The minimum value of this subtree is basically 10. So if we find out the minimum value, then just swap these two values. Now put the value of 10 here and put the value of 8 here. So after swapping, you have to recursively call that delete function another time. So if you delete function another time, so now this 8 is the leaf node of that particular binary search tree. So you just simply delete it, as we discussed how we can delete the leaf node in the case 1. And so after deleting this node, can it just maintain the binary search tree conditions? Let's see it. So you can see here that 10 is lesser than the 20, so it is in the left. That's okay, that's fine. And 4 is lesser than 10, it is in the left. That's also fine. 12 is greater than 10, it is in the right. And 14 is greater than 12, it is in the right, in the right of the 12. So the conditions of the binary search tree, that left nodes are always lesser and the right nodes are always greater, is satisfied after the deletion also. So that's how you can delete a particular node from a binary search tree. Now let's discuss how we can code this particular solution. So here is the function of delete node. Now the base case will be of this function will be whenever this root is null. Okay, whenever this root is null, you have to simply return that particular root. And one condition will be the root value is the x value what we have to delete is lesser than the root value, then obviously the node is left of that particular root. So you can see over there, if x is lesser than of root of data, then it will be in the left side. So root of left will be equal to of delete of node root of left and this x. Okay, similar thing will be done for the right node. Whenever this x value is greater than of root of data, that means x is greater than of root of data, at that time you have to just write this thing, root of right equal to delete of node and root of right of x. So this is the two condition we taken care of. Now the condition, whenever the x is equal to root of data, if x is equal to root of data, that means we have to delete this root now. So we just write else over here. And now when you want to delete a node, as we see in the diagram or whiteboard, that we have to taken care of three cases. First case is when you have no child. So we don't need to consider about that. It will be covered in the later codes. So the second condition is that when you have only one child. So let's suppose if it's uh, left child is null. So that means if root of left equal to null, then what you have to do is that you have to just create connection from the right to its parents. So I'm just storing the right and then just deleting this node, deleting this particular root, and then just return this temp. Same thing will be done for the right child. So root of right, if root of right equal to null, then what you have to do, you have to just write temporary variable equal to root of left. Okay, you have to declare the temporary variables as well, na? Otherwise it will give you the error. So yeah, so root of left, we store the root of left, and you have to just delete this root and just simply return this thing. Now the final condition, when you have both the childs, for that what I told you, you have to find out the minimum of the right subtree of that particular node. So for that you just I just take a node which is current, initialized it with root of right, as we have to find the minimum of the right subtree. So and then run a while loop until and unless this current is equal to null or current is not equal to null and current of left is not equal to null. So whenever you do that, you know, in every loop you have to write current of left. Yeah, so that's how you can just traverse to the minimum element and find the minimum element. After finding the minimum element, what you have to do, you have to just swap that thing. So you have to write integer of temp, which is basically nothing but of current of data. For that you have to just replace this current of data with root of data, and after that this root of data will be replaced by temp, and you have to call this delete function recursively now, so that it's delete the current, the minimum what we have swapped. Okay, so for that basically you have to write this thing, delete of node, you have to write pass on the root of right and x. So after deleting this, at the end you have to return the root. So this is the basic function how you can delete a node from a binary search tree. Hope you understand the code. If you doesn't, then you can see the whole code from my blog as well. The link will be in the description. Thank you very much, and let's do hit the subscribe button and like this video and share with your friends. Thank you.